Hello and welcome to this presentation on challenges in manufacturing environment for 5G networks and how to overcome them. So I'm Ibrahim Kassaji. I'm an analyst in Analysys Mason's research division, and I focus on IoT and private networks. And presenting today, we have Jagadish Dantuluri, who's the General Manager of Private and Dedicated Networks at Keysight Technologies. So Jagadish is going to present for about 20 minutes or so, and then we'll have 10 minutes of Q&A. So please do send in your questions as we go along, and then we'll pick them up at the end. So without further ado, over to Jagadish.
Thank you very much, Ibrahim, and hello, everyone. Thank you very much for taking your time today in joining us. So today, to just give the background, I lead a business called Private and Dedicated Networks at Keysight Technologies. In my role, my goal is to understand the market in this exciting new area, particularly the Industry 4.0, and bring solutions from Keysight Technologies to the market. That is my role. But here today, as we are, Keysight is going to the market, working with our customers, we did understand many of the challenges that our customers face. So today I want to briefly introduce some of the challenges that our customers are encountering when they deploy private networks. So with that, before we go into some of those challenges, what I would do is at a very high level, briefly introduce what is the network lifecycle, or maybe at a very high level, what the challenges are, and then talk about some unique challenges that are very specific to the manufacturing sector. So with that in mind, so if you take the network lifecycle, which is the private networks lifecycle is very similar to the commercial deployment network cycle, where it starts in the build phase, where companies do the research in building, researching the new technology, and then build the devices for that new technology or the network, and get those certified, validated, and then take to the market. In the market, people who are in the business of deploying or planning, they take those solutions based on the use case, whatever they are deploying. They do the planning, they do the design of the network, and then deploy the network. And then once it is deployed, they also make sure that the network is running fine. Network has all the quality that it is designed for. So after that, it goes to the operations, which typically what we see is today the big operators running their networks. So there is a lot of network monitoring that needs to happen, and then the optimization based on the network quality. If the quality is deteriorating, or if they need to upgrade, they need to optimize the networks again. So this is a normal process, which is very similar in the private networks also. The main difference would be that, hey, these networks are small. The end users, typically in this case, let's say the factories in the manufacturing scope, they typically are not very well aware of the technology or knowledgeable of the technology. So that's the reason the surrounding ecosystem has to help this industry to bring these networks to the market. So having said that, before a network is deployed, one of the main things is the network has to be designed. So what are the things that need to be considered while designing a network? The first and the foremost thing is about, hey, what is the use cases, right? A use case for let's say a car manufacturer may not be the same as let's say a textile clothes manufacturer, right? So the requirements are quite different, and so the quality or the network designs would be quite different based on those requirements. So the same thing goes, hey, is TSN required? Unless there is an equipment that is running on the TSN, why a TSN need to be there? Some of those things have to be considered about, hey, what is my use case? What should be my network design supposed to be? And then, of course, spectrum. Many people talked about this before as well. Spectrum is one of the most important things for private networks. In certain countries like Germany, Denmark, or South Korea, where the government is really allocating private dedicated spectrum, which can be used by the enterprises to deploy the network. Whereas in other countries, they have to rely on the public carriers to get that spectrum, or maybe in USA, a different mode like the CBRS frequencies can also be used. So spectrum is an important thing that need to be considered. Of course, the deployment models, do you rely on the 5G SA slicing by taking the private network from a public operator, or do you have your own private network deployed? Depending upon the use case, that may be a consideration. Of course, the internetworking, which we talk in a bit more, will the new systems interwork with the existing system? Will the new technologies like 5G need to work with the existing networking technology, be it wide or wireless, that need to be considered as well? And then, of course, the interference is a very important issue, partly because the mission critical application, in this case, the manufacturing, if it has to be put on a wireless technology, then that network should not have the interference issues. So that need to be taken care well. And of course, the security is the most important thing. So these are the main, broadly, the challenges when a network has to be designed. But coming to the agenda of this meeting, let me now introduce three unique challenges that the customers are facing in the manufacturing sector. The first one is, let me introduce by talking about the manufacturing indoors. If you see, these are various sectors manufacturing, be it auto, be it metal casting, or be it leather manufacturing there, or process industry, or many of these things. If you see, each of these indoors are unique in the sense they are designed for the specific manufacturing use case. In some cases, there can be more metal. In some other cases, there can be less metal, or it can be concrete. So when some devices are designed, typically the consumer network devices are designed, they typically take care into consideration of the radio propagation models of, let's say, a city, or maybe a rural environment. And they design their devices and their radios based on these propagation models. While in a factory, typically the indoor is quite unique. You have a lot of sensors, a lot of metal, and all these things typically are not considered when designing a typical radio, a typical device. So what is the problem if these devices or the radios are installed in the private network in a manufacturing facility? There can be scattering effect, there can be reflections, refractions. So the performance that you are expecting when a network is designed, or what you are expecting from the devices and the radios, may not be the same thing that you would get in the real network. So in order to overcome, what needs to be done is before the network is deployed, or before the network is commissioned, one need to ensure that the radio propagation models that these devices work with, or the radios that are configured, should give the optimal performance for the unique indoor environment in the manufacturing. So the way that can be solved is something like this. So one way to do that is, let's say, you take the, so the one way to solve that is, hey, design a network so that you use a high fidelity planning tool, which is different than the conventional SNR based blur estimation solution, so that you'll get a deterministic performance all the time. So one way to do that is, let me explain briefly with a simple block diagram. So here, if you see, this is a radio, this is the indoor environment with a specific and unique material that is in that particular factory. Based on that particular data about, hey, what is the size of the factory? What is the material that is used? Is it a metal? Is it a concrete? Based on that, a race tracing data can be processed in a H-metric GCM software, which is readily available in the market, to create a H matrix. This H matrix then will be used with the real life 5G waveforms. These waveforms can be generated synthetically, and then that will be convoluted with the H matrix to generate a specific output data. This output data will have the real life radio waveforms, which can give you what kind of data throughput, what kind of blur, those kind of things can be measured. And that is basically you generated something in the software about the performance of your network by generating the H matrix based on your factory and then convoluting that with the real 5G waveforms. Now go take that H matrix and put that inside the real G node Bs and generate the same 5G waveform that you have generated at the top. And now record the performance of the network. And when you compare this real life performance with the lab performance, if it is close to what has come in the lab, then you got the optimal network. If that is not the case, then you go back to the lab again and then redo the same process. So what is the advantage of this thing? So you would decrease the number of iterations that you would do to get the optimal performance, number one. Number two, you would get the optimal performance instead of blindly going into the field and expecting that the performance is as expected based on the designs that were done for the commercial networks. And so to go into a little bit more details, this is how we do Keysight, and this has been implemented in multiple installations, not only in the commercial networks, but also in the defense sector, and it has proven to be working. And so here we have some software that is taking the H matrix that is generated by the GCM and generate some waveforms. Then we use the 5G waveforms and then send through the same H matrix, convolute that, and generate the output data, which can also be used in many other forms. Maybe use the real hardware like a channel modulator and generate the same data. And in the real life, use the same H matrix and put in the G node B, and then send the same waveforms and get the output data, and then compare with the lab generated data. So in this way, basically one can optimize their installations about where the radios need to be put in a factory floor. So that is one challenge that is very unique to the manufacturing. Let me go to the next challenge. The next challenge is, again, before I go, I think this is about comparing the data output between the software and the hardware or the real data, and see if there are differences, then the designs can be optimized. Now, going to the next challenge, this picture, if you see, there is an AMR, right? Of course, people are talking a lot about AMRs, AGVs in the factory floor. One thing that is unique is, these need to work in a factory floor where there's a lot of metal around, right? And the other important thing for these AMRs is they work autonomously as far as identifying the next step is. That means they need to constantly communicating with the robotic management system to find the next step. And for that, the coverage of the radio and the quality of the radio and the quality of the network has to be very good. Again, this is one type of device. But there can be many other devices in the manufacturing facility. They can be wireless sensors, they can be level sensors, or they can be 5G adapters like these, which are legacy technologies, which are being equipped with the 5G technologies today. And then you also can see some 5G gateways with Profinet, Profisafe kind of protocols installed, or you can have these kind of wall terminals, remote IO, whatnot. All these things are industrial devices, not the consumer devices, and each has some unique characteristics. One of the most unique characteristics of these AMRs, for example, is that they constantly send signaling message, and the data traffic is bursting. And if there are many number of AMRs working in the same network, they send a lot of simultaneous bursty traffic. This bursted traffic, and particularly because of the signaling traffic, it can create a lot of load on the network. And there are instances where the core network has crashed because it could not handle the amount of bursty or the signaling traffic that is being generated by these devices. And so one way, which is again unique to the smart manufacturing or smart warehouses, and this need to be taken into consideration, and it needs to be tested. One way to do the testing is, for example, when the network is being commissioned or just before the commissioning, let's assume that your network capacity is 10,000 devices with many smart sensors, and let's say 200 AMRs. on day one, you would not have all the smart sensors and other things connected to the network. One way to do before the network is commissioned is, hey, connect 50 devices or 20 devices, what are available, but emulate or simulate all the other IoT devices with their network profile. For example, it can be AMR network profile with a lot of signaling data, a lot of bursty traffic. Use that traffic and make sure that the network is stressed enough that the network stands for the new type of industrial traffic. That's the other challenge that we see typically in the network, and it is an important application and use case that we are seeing in at our customers. Then the last and the most important thing that I want to talk today is about interference. One thing about manufacturing is a half an hour stoppage of an assembly line or any of those things can create losses in the tune of millions, right? Depending upon the customer, of course, depending upon the use case and other things. But again, any stoppage is a loss, right? So if that particular application is installed using 5G wireless technology, you want to ensure that that 5G network is working all the time. And interference is a big issue. Where can the interference can come? This picture is a depiction of an assembly line where the raw materials are coming from the left-hand side and the finished goods are going in the right-hand side. And if you can see, there are many industrial equipment, be it AGVs, AMRs, all other things are connected with 5G. And you have smart workers with 5G headsets or video cameras, all connected to the 5G network. So now where can the interference can come? It can come from many forms. It can come from a air conditioning plant, which is very close by, or it can come from a traditional cell site, which is very close to the factory, or it can come from a faulty device inside the factory, or it can be from a malicious actor who is sitting outside the factory and trying to send some jamming signals. Any of these things can create interference and jamming. And when the interference has happened, the performance of the network or the devices will decrease. So this has to be avoided. One way to avoid this thing or to identify the interference and possibly eliminate that is to constantly monitor for the interference signals. So which is basically to sweep all the frequencies around and see if there is something unwanted frequency that is coming into your space, identify the source of that frequency and then eliminate. So these are some of the three challenges that I want to talk today, which are very, very, very unique to the manufacturing facility. With that, let me pause here, Ibrahim, for any questions from the audience.
Yeah, great. Thanks, Jagdish. So we've got a couple of questions in, but please do keep sending in your questions now. We'll try to get through as many as possible. So the first question is on the life cycle that you mentioned at the beginning, and saying how long is the build and the plan deploy phases, and kind of how does that time frame compared to say an LTE private network or other technologies?
So I think like anything, right, it all depends upon the factory or depending upon the what is the end application, isn't it? For example, a textile manufacturing facility where the QoE requirements are very less, or the penalty of a stoppage of the network is very small. In that scenario, then the deployment will be very faster. But we also have seen few other deployments where the POCs are taking an year. It's not necessarily about just the wireless technology. It's also about upgrading their existing systems to the new systems, or maybe enabling their existing systems to interwork with the new systems. That takes a lot of time, and the POCs would take a lot of time because they need to ensure that all these things work together. If there are any failures, what are the how can those failures can be bypassed, or if there is a redundancy path. So it depends upon the application, but typically if you just take about the network itself, the network can be upgraded within 3 months, even for some of the most critical networks, or it can take just years in POCs as well.
Yeah, great. And we've got another question. I think this relates to the solution part and tackling the challenge. Is this kind of effort required for every single project? How common is the solution required, or only for typical plants?
So this, I would advise to this for any manufacturing facility. Why? Because the indoor environment in every manufacturing facility is quite unique. One cannot rely on the commercial grade equipment that they will give the optimal performance. Particularly, the metal has a lot of reflection and scattering effect compared to the traditional buildings that we have in our offices. And so it is imperative, in my opinion, that this particular custom channel modeling or the RF channel modeling has to be done for every manufacturing facility. And we have experience as Keysight helping the defense sector, particularly in this area. The reason for them is for them, these private networks are very mission critical. And so they take these things and for every private network, they do go through this process and optimize their networks. And so for manufacturing, I would say it is very similar.
Yeah, sure. So we have a couple of questions relating to quality of service. So firstly, how do you test traffic quality of service? And secondly, could you talk about how you ensure critical real-time systems get the desired quality of service, like an AR/VR session doesn't hog the AMR traffic?
That is correct. I think that is let me take the second question first. I think in the 5G, right, you have an ability to prioritize and give a certain quality of experience for any type of traffic, and that can be configured. In that sense, for example, if you take the AR and VR, typically the use case there today, at least, is about training, the new employee training, or maybe for the repairs of a machine, right? That I would say, at least naiveness, without going into the details, that it might be lower priority compared to the AMR type application. And so one can configure the AMR type traffic at a higher priority compared to the XR and VR traffic. And that's how it can be solved. And can you repeat the first question?
So the first question is, how do you test traffic quality of service? And are you working with specific traffic generators?
Yeah, so I think as far as the traffic generator, Keysight has the ability to generate industry-specific traffic from one side. For example, in the picture that I have shown is, I said, hey, you have a UV emulation, you should be able to generate, right? So in this case, the left-hand side, let's say if you want to test the quality of the network, we have the ability to generate the traffic profile just for AMRs or just for wireless sensors. Each of those networks or the devices have a unique traffic profile. If I go a little bit more, there is a SCADA type traffic, the IoT sensors type traffic, or the PLC type traffic. Each of those, the traffic is a little bit different as far as the signatures are concerned. And so we have the ability to generate these things in the left-hand side and have the application agents interworking with each other per device type and stress the network. And as far as the measurement of the KPIs, at least the software has the ability to measure the KPIs that are unique for these applications, and also the network level KPIs, be it round trip time, be it error rates, blur, packet drops, etc.
Great. Yeah. So we have a question on ORAN. Question says, do you see any benefits of having an ORAN solution in your deployments?
Absolutely. I think, again, if you take business and philosophically, anyone would install a network. It's not about because a new technology is available that one installs, right? It's all about, hey, what is my business case and what is our ROI, which is quite common, and everyone will say that. And so we have, at least based on our experience, when we measured the initial deployment of ORAN-based technology may be tough because of the integration challenges, but over time, the cost of deploying ORAN would be much cheaper. And it also gives an ability for vendor diversity. Today, if you think that the system integration is a big challenge, go with a single vendor who provides all the components from ORU, ODU, and even the core network as well. But over time, if you don't like that vendor, you can always have an ability for vendor diversity, number one. Number two, if there are any new feature, if one vendor is not providing, you can go to the next vendor. And because of the vendor diversity, overall, the cost will be cheaper. And that at least in on paper, it has proven.
Yeah. We have a question about what are the specific challenges when deploying multiple technologies and also when integrating with existing technologies and non-5G?
Very good question. Again, if you take a step back about what are those multiple technologies, right? Number one, it's easy to say, hey, today, many of my devices are connected with wired connection or Wi-Fi, maybe in some cases. The new technology can be 5G. Hey, how can those two work together? There may be cases in the new scenarios, let's say wireless sensors. Yesterday, there was no ability to connect that sensor with a wire, and there is no way to put that sensor in that particular location. With wireless, probably there is an ability to connect that sensor at a location to get the data. Now that has to be integrated with the existing technology. So then it means there should be enough tests that needs to be done to make sure that the devices that are connected on the wired work with the devices that are connected on the wireless technology. Then the other examples that can be told is, let's say in a deployment where there is TSN. TSN, there can be controllers, there can be end devices. The controller can be connected with a wired connection, and the end device may be on a wireless connection. That means the TSN, the signal that is going on from one side to the other side, has to traverse from the wired side technology to the wireless technology. And so that is an integration challenge that has to be tested thoroughly. And then one other example that can be taken as a PLCs, right? The existing PLCs, they don't have wireless technology. And tomorrow, possibly those PLCs may have wireless technology. And so if you have multiple PLCs working in the same manufacturing plant, and if there is a communication need between those two, then one need to ensure that the communication has to happen reliably between those two. And that has to be tested again. So again, then that kind of brings about, hey, what is the protocols that you need to be testing? It's not just about network protocol. I also have TSN protocol or maybe other application layer protocols that are working between these things, and that has to be thoroughly tested. Again, in one way to do is the picture that I'm showing here.
Yeah. So I think we might have time for just one more question. So the question has come in, is it really feasible to have so many signals inside one facility, and how will you manage all these different signals?
By that, I'm assuming the signal they're talking about wireless signals, right? If that is so, yes, I think that's a very good question, but let's take a step back, right? In the commercial networks, typically you may see in a particular cell, sometimes 5 to 7 different frequency. In a factory, particularly in the private network, you don't need that many frequencies. Typically, it can be one cellular technology frequency, be it 3.7 or 4.2 gigahertz, and a Wi-Fi signal. And so the installations would be much more simpler than we think about. There may be one or two, right? And you've got to ensure that there is no interference between that Wi-Fi technology and the cellular technology. That's one aspect. The second aspect is about, if we talk about the interference that can come based on deliberate malicious actors, that can come because of faulty devices, or that can come because of some other unwanted devices like an AC machine that is generating that frequency. All those things have to be monitored. I think they have to be sweeping that particular frequency range to identify those frequencies and possibly identify the generator of that source and eliminate it.
Right, yeah, good question, John. And just quickly, Jagdish, we've been asked, will the slides be available for attendees?
The slides will be available to download. I did mention to Manan to enable that. And of course, Keysight.com has a very good information about all these technologies as well. But we're glad to speak with anyone on these things to go a little bit more details as well.
Great, yeah, and just to echo that, if anyone has further questions or discussion, please reach out to Jagdish or myself, and yeah, we're happy to talk further. So
Awesome.
yeah, thank you for listening.
Awesome. Thank you very much, everyone, for taking your time today. Thank you.